In this question and answer session, we covered Venn diagrams, linear equations, loci, prime factorization, and highest common factors. Sierra was nice enough to allow me to record it and post it on YouTube, but I apologize because the software I was using to record the audio messed up, and well, you'll be able to hear that something went a little bit wrong, but I hope it's not too annoying for you to watch. Also, the cursor on my computer didn't show up in the recording, so you can imagine when I'm asking questions and I'm pointing to things, it might seem a little bit confusing when you're watching this video. The reason I'm posting this video is because exams are a stressful time, and whatever questions you have about any particular topics, there's a high chance that other people have those exact same questions. So it can be good to share those questions with other people. If you'd like to be part of a question and answer session like this one, leave a comment down below letting me know. So when you started this problem, where was the first place where you got stuck?
It's probably the symbol.
Okay, so this notation, you didn't understand what this meant. Okay, so this means the number of elements in this Venn diagram. So, a typical Venn diagram gives you the universal set, and it will give you, a number of numbers, right?
Yeah.
Maybe there's 10 numbers in that universal set. This Venn diagram is different in that it's telling you the number of numbers in the sets, not the actual numbers themselves. Does that make sense?
Yeah.
So this notation means the number of elements in the sets. So we know that in total in this Venn diagram there are 40 elements. So there are x plus 4 elements in A minus B.
Yeah.
There are 3x elements in A intersect B, and there are 2x plus 3 elements in B minus A, and there are 9 elements outside of those sets. And they all add up to 40, okay?
Yeah. Yeah.
So what that allows us to do is to create an equation. So we can say that x plus 4 plus 3x plus 2x plus 3 plus 9. So I've just added all of those elements up together.
Okay.
They must equal 40, right?
Yeah.
And you can see here, what do you think my next step is with this equation?
Would you simplify it?
Simplify, exactly. So I can take the x's, so there's 1x and then 3x's and 2x's, so that makes 6 lots of x. And then I can add the 4 and the 3 and the 9, that's going to be 16. And that all equals 40.
Yeah.
And then I can continue solving this. So this is going to be 6 lots of x equals 40 minus 16. That's going to be 24. So x equals 4.
Yeah.
Okay, so that's my answer for part A.
Okay.
Did you have a go at part B as well?
No.
Okay, so part B says an element is randomly chosen from the universal set E. Find the probability of A intersect B. So these two symbols are commonly used in Venn diagrams, the U and the upside down U. So the U means union, and that's everything inside A and B. And the upside down U is intersect, and that's everything inside the middle part of the Venn diagram, the intersection of A and B. So we want the probability, and it doesn't say probability in the question, does it? It just puts a P there. So that means probability of A intersect B is going to be how many elements in the intersection divided by the total number of elements in the universal set. So remember that x equaled 4, right? That's a key part of this question. So how many elements in A minus B in this part here?
2.
Careful.
There's x plus 4 and 2x.
And what did x equal?
Oh, 4.
Yes.
So it'd be 8.
Fantastic. And how many elements in B minus A in this part here?
11.
Great. So how many in the intersection?
12.
12. Great. So there are 12 elements in the intersection. And how many elements in total?
31.
Well, they tell us, don't they? They say there's 40.
Oh.
Yeah.
Okay. Yeah.
There are 31 in A and B, but remember we
Yeah.
need to include that 9 as well. So
Okay.
so the probability of choosing an element from the intersection is going to be 12 out of 40.
Okay.
And then we can simplify that. So if we divide by 4, we'll get 3 over 10. And I believe that's your answer. So that's how you're getting to the answers for those. Does that all make sense?
Yeah.
Okay, fantastic. Okay, so this question says, in the diagram, ABC is the line with equation y equals half x plus 5, AB equals BC, D is the point with coordinates minus 13, 0. Find the equation of the line through AD. Where did you begin with this problem?
I didn't really try it too much.
Okay.
Because it looked very difficult.
Okay. Having a look now, where do you think you could start?
Finding the gradient or something. I'm not sure.
Yes. That's exactly right. You need to find the gradient of AD. And how can we do that? Well, we can firstly, there's 2 points on the line ABC that we can find. There's B, the point B, which is the y-intercept, and that will be 0, 5, based on this equation that they give us. So if x is 0, y will be 5, so that's the y-intercept. Point C will be the x-intercept. That's when y equals 0. So if we put 0 in for y in this equation, we can solve for x. So 0 equals a half x plus 5, and then a half x equals minus 5, so x must equal multiply minus 5 by minus 2, and you get 10. Okay? So the x-intercept there is 10, 0. And what this does is allows us to find point A. And why do we need point A? It's because once we have 2 points on any line, we can find the equation for that line. And we already have point D, so once we find point A, we can find an equation for AD. So we can use these 2 points to find A because they tell us that AB is the same as BC. So if we look at C, C is at 10, 0, and B is at 0, 5. So let's start at C and travel to B. How far left will I have to go to get to B? How many units left? If I start at C, sorry?
I'm not sure.
Okay, so if I start at C and go to the origin O, I need to go 10 units left.
Yeah, okay.
And then if I go up 5 units, I'm at B. So I've gone 10 units left and 5 units up to get to B.
Yeah.
So how can I get to A from B, do you think? Keep in mind that AB and BC are the same length.
Would you go 10 units?
Yep, 10 units left from B and 5 units up again. So if I do that, from 0, 5, if I go 10 units left, I'll be at minus 10. And 5 units up, I'll be at 10 on the y-axis. So point A must be minus 10, 10.
Yeah.
Is there anything in there that didn't quite make sense?
Yeah, that made sense.
Okay, great. Now, in my opinion, that's the hardest part of the question, finding point A. Because now if you've done this process before, you can take those 2 points D and A and find the equation for the line AD. So let's go ahead and do that. So the first thing we need to do is to find the gradient of AD. And we can do that using the rise over the run.
Yeah.
And to find the rise, we can do y2 take y1 over x2 take x1. Have you done that before?
Yeah.
Great. So we can take 10, and by the way, point D, let's just write D down firstly. So D is minus 13, 0. So y2 is 10 and y1 is 0, so 10 minus 0 on the top, and the run will be minus 10 minus 13. And so on the top line we get 10, and on the bottom line we get minus 10 plus 13, so that will be 3.
Yeah.
So for the gradient, we're going to get 10 over 3. I would generally leave it like that, or it could be 3 and a third, depending what you're most comfortable with, I guess. So we've got the gradient, so we can write, so the equation of AD is looking like y equals 10 over 3x plus, now do we know what the y-intercept is yet?
No.
No, so we can't finish this equation off, so we have to fill in that blank somehow. So we just write a c, we just put an unknown in there, and we need to use a point on the line again to find what that unknown is. So I'm going to use D, because I think that might be easier. So if I use the point D, so I can say using D, which is minus 13, 0, I can substitute those points into this equation. So y is 0, x is going to be minus 13, and then add c. And what this allows us to do is to find the value of c. So I can solve this equation to find c. So 10 over 3 times minus 13, that's going to be, what's the easiest way to do this? That's going to be 130 over 3 plus c. And then c, and then I need to add that to the other side, so c is going to be 130 over 3, and then if you simplify that, well, 3 goes into 120 40 times, so that's going to be 43 and a third. So the equation becomes y equals 10 over 3x plus 43 and a third, I believe.
Okay.
Does that make sense?
Yeah.
Okay, so any questions about that question before we move on?
No, it makes sense.
Okay, fantastic. Yeah, as I said, I'll see if I can bring up that paper actually and show you the question that I mean. Can you see this on the screen right now?
Yeah.
So this question is pretty similar. So if you want to have a go at this one afterwards, maybe if you can get that by yourself, then that would be showing progress. So okay, let's go on to, was it question 11 or 12 that you were struck, or both?
Yeah, wait. Yeah, both.
Both, okay. So let's have a look at this loci question. So this says, the scale drawing shows the position of 3 hospitals A, B, and C on an island. It gives us a scale, and it says an ambulance takes a patient to hospital A if they are within a 30-mile radius of this hospital. Otherwise it will take the patient to hospital B or C depending on which is closer. Sarah calls from her home for an ambulance. The ambulance takes her to hospital B, shown on the map the region where Sarah lives. The first thing we can do is to draw a circle around A.
Okay.
And that's simple enough because we could just set our compass to 3 units, 3 centimeters, and draw that circle, and that makes sense. So
Yeah.
it's obviously not going to be within that circle. So that's a pretty rough circle, but you get the idea. And
Yeah.
the next thing we need is the line between B and C that divides the distance in half, or we call that the line of equidistance, where every point on that line is equal distance from B and C. And the way that we find that line is by drawing the perpendicular bisector of B and C. And we can construct that using just a compass. So if you take your compass and center it on B, and then make sure the distance of the compass is over half the distance between B and C. So there's no point drawing a circle like this around B because it's not going to help. So it needs to be, it doesn't matter what the distance is exactly, but as long as it's over half the distance between B and C. So let's say you drew a circle about with a radius of this size, and you need to draw about half a circle, and then center the compass on C, keeping the distance the same. So that the radius will need to be the same as the one around B. So then you center it on C and draw your circle again with the same radius. And once you've drawn those two half circles with center B and center C, where those circles intersect will be the bisector of B and C. And then you take a ruler and you draw a line through those 2 points. And so that's the bisector. And then the question says, show on the map the region where Sarah could live. So Sarah could live in this region in here, because they take her to hospital B. So anywhere in here, the ambulance would go to hospital B.
Okay. Yeah.
Okay.
Yeah.
I'm guessing that the drawing that line was the difficult part in that question for you? Yeah. Okay. That comes under the topic of loci in GCSEs and constructions. All right. Okay. And now let's have a look at question 12. P equals 2 cubed times 3 squared times 5 times 7. Q equals 6 over 7p. R equals 4 over 15p. Work out the highest common factor of Q and R. What we need to do is to substitute P into these equations, simplify, and then find the common factor. So we could work out what P equals, but we end up with, I think it was 2,520 or something. And then we're going to end up with two really big numbers, and then we're going to have to try to factorize those. So what we want to aim to do is to keep P in its factorized form, in its prime factor form, and hopefully that's going to keep things easier. So let's substitute P into Q and then simplify. So let's see. So firstly, writing out P, 2 cubed times 3 squared times 5 times 7. And then I'm just going to write this slightly differently. So I'm going to multiply all of that by 6 and then divide all of it by 7. Are you comfortable with that?
Yeah.
That's exactly the same as this equation. I've just rearranged it slightly. So now what I can do is to, just like a normal fraction, I can cancel the common factors between the top and bottom sides. So I can cancel those 7s. And I'm going to change this 6 into 2 times 3. And so I can simplify Q into, now I've got a 2 cubed and a 2 here, so that's going to be 2 to the power 4. And then a 3 and a 3 squared here, so that's going to be 3 cubed. And then I've got a 5 there. So Q simplifies to 2 to the power 4 times 3 cubed times 5. And I can do the same thing with R, so I'll substitute P into R. So I've got 2 cubed times 3 squared times 5 times 7, multiplied by 4, all divided by 15. Now this is slightly more complicated because I don't have a 15 on the top line. However, I can create 15 using 3 and 5. So if I take one of these 3's and multiply it by 5, I get 15. So, and then I can cancel that with the bottom line. And then I can turn this 2 into 2 squared. So what do you think this will simplify to in the next line?
2/5.
Yes, exactly. 2 to the power 5.
Times 15.
Careful, because what I've done is I've cancelled that 15. And
so would it just be 3?
Yes, just be 3, well done.
Times 7.
Fantastic. So R simplifies to 2 to the power 5 times 3 times 7. And have you ever found the lowest common multiple and highest common factor using Venn diagrams?
No.
Okay, so what we can do to find the highest common factor is to sort these prime factors into a Venn diagram. In this set will be the prime factors of Q, and in this set will be the prime factors of R, and the elements in the intersection turn out to be the highest common factor. So the first thing we need to do is to find the common elements between Q and R. So if I've got 2 to the power 4 and 2 to the power 5, I can write 2 to the power 4 in the intersection. And then I've got one lot of 3 over here and 3 cubed over here, so there'll be one lot of 3 in the intersection as well. And then everything else just goes into their own sets. So for Q, I have a 3 squared and a 5, and for R, I have one lot of 2 and a 7. Now it's really easy to find the highest common factor because all I need to do is to take that 2 to the power 4, multiply it by 3, and that gives me the highest common factor. So 2 to the power 4 is 16 times 3, and that's going to be 48. All right?
Okay. Yeah.
Okay, fantastic. So yeah, that was all the questions that you wanted to go through. Is there anything else I can help with?
No, that was all right. That was it.
Okay, fantastic.